Hello everyone, in this video I want to show how to implement the second project, and then I will run my implementation to show how to run it. So the second project is about client-server token manager. We will define a token message data structure. It will contain ID, name, domain, and state. And we'll use the Google protocol buffer, and then we will use Google RPC to call it from the client side. So the structure will look like this. First, we define the protocol buffer, and because we want to use it in Google RPC, so we need to compare them using Google RPC compiler, and then we implement those methods we need in server side. After that, everything is done, we can call those methods in server side from client side using Google RPC. In the load section, I write down all the things you need to do, and actually they are good summary for the official websites and list all the reference I used. For the protocol buffer, before this project, you of course need to understand the basic concepts of the protocol buffer. And you just go through those websites, and I think one good example is like here. So the protocol buffer, it defines, it's like a JSON or XML. It defines the message structure we are going to sending and receiving. But how to send and receive, we will use Google RPC. So also you need to go through those websites and install them, make sure it works. I think the Hello World example is good enough and it's simple for us to understand the basic concept. So for this project, you need to define our own protocol buffer. You need a file called whatever dot portal. In this file, you define the message structure. We can check it here. This is our token.portal, and we just define the message. This is the message structure in assignment PDF. So the ID, name, domain, state, blah blah blah. I add this message just for my own using. I use it to send success or fail. After you define the message, you can compile it using the protocol buffer compiler, and it will generate a file called token.pb.go. So in this file, you can see that everything this is generated by protocol buffer compile, so don't edit. You can see the structure, message structure, and it also has other it generated for us, like getter, setter, blah blah. Those getter method, you can just use them. So after we have those message structure, you can read and write messages. If you just want to read from or write to variables, like this project, we can just use some instance. I mean, you create a instance for this message structure. If you want to read from or write to files on disk, the protocol buffer, it has official web method called marshals and unmarshals to help you to read from and write to files on disk. But in this project, we will only need this part. We only need a variable which will be a list holding all those tokens. And then if we want to use Google RPC, we need to add something in this portal fields, that is the service. We need to add them. They are actually like interface. You define the method, the input, the output, the method signature. After we define those services for Google RPC, we then use another compiler we need to install the protocol buffer compiler with special plugin, like this one. After you installing them, just run it, and this time you will have two output files. So the first file it generated is this one. It will be same as we saw in step 1, and the second one is this one. So the token underline gRPC.pb.go. In this file, it will implement those interface, those service we defined in portal files. And we can see that create one token, it will be this method, and then the write and the read and the drop and get all. That's all the methods we defined in protocol file. It will implement for us. And also this is generated by the compiler, and don't edit. Those are the protocol buffer and Google RPC parts. After that, we need to do more stuff for our project. All we need to do is you define your own server.go file and you implement them. You import all of them, and also then you define your own server structure. So you can see it's called pb.unimplemented token service server. And then you can see where we use it. You can implement your own methods in server side, like create one token. So after I receive the message I get from client side, I will first check does it exist or not. If it exists, I will say sorry, it already exists. If it's not exist, and then we will create one for each. So we just use the ID of each when we create one. We haven't defined the domain or the state or those stuff. That's it, and then we return message to client side. So it's similar for the write one token method. After I get the message from client side, I will go over all those token lists I stored locally, and I will check which one is the one you are writing. After I find it, I just change those name, domain, state, everything to what you give me, or use the argmin hash function required by professor. If everything go well, I will just tell you the message. I will return the message is good. If it didn't find it one, I will tell you no, sorry, it's not found. So similar for those read one token and drop one tokens, you need to implement them. And for this main function, you can see it's almost the same. I reused the hello world example from Google RPC official example. After you implement those methods in server side, you need to implement those methods in client side. So like you need to first you need to deal with those flags. You can just use the Google official flags package. It helps. You check all those flags, and then it depends on which flags do we get. So that's if else, or you can use switch cases. If is create, if write, if read, if drop, that's it. Don't forget to print everything after each command, so you can check the changes caused by your commands. Okay, that's everything. And also I want to mention that don't forget to use Go model. If you finish project 1, I think you know how to do that. If you use Go mode, that means other people, whoever download your code, they can run your code in any directory they want. They don't need to configure Go root, Go path. So use Go model, please. Next, I want to show you guys how I run it. So firstly, I go to a project directory, and then this side I will go to the token servers directory. And then I just run the command. We need to give them permission. So at this moment the server is up, and then we can run the client side. So the bottom windows, I will go to the client. And I will run the first create command. It will create one message, and it tell me it succeed. And in the server side, I print all the token I got. And then we create another one. This is the same one. This is the same one. For this, if you create same ID 2 times, it will tell you it already exists. So it tells you failed, and it says it already exists. And then I will create a new one. That's 1, 2, 3, 4, 5. Yes, it is say success. So I print all the token I have, that is 222 and 1, 2, 3, 4, 5. And then I will create one more. It says succeed, and it print all the tokens I got, 222, 1, 2, 3, 4, 5, and 222. And then we can write. Just write them quickly. So the first one succeeds, and the second one succeed. 1, 2, 3, 4, 5 succeed, and the third one is just write ID 2. It will give us fail. So it says fails because the ID 2 was not found. So here we can check the server side. The 222 is never wrote. The 1, 2, 3, 4, 5 is wrote successfully, and the 2222 is read successfully. And then let's go read. So the read success. If we read 1, 2, 3, 4, 5, it will convert. It succeeds. And if we read 1, 2, 3, 4, it will give me fails because it doesn't exist. Right? It's not found. It doesn't exist. We don't have 1, 2, 3, 4. And then we can drop. Let's just drop the 1, 2, 3, 4, 5. The drop succeeds, and the server side we can see it has only 2 left. After drop, if we read it again, it's no longer there. It say was not found because we don't have it anymore. So that's the result of running. I hope this video is helpful.